Assalamu alaikum warahmatullahi wabarakatuh. Dear students, in this video we will solve examples of practice set 1.2 from the chapter Similarity. The examples are based on basic proportionality theorem and its converse, then angle bisector theorem and its converse, and property of three parallel lines and their transversals. Now let us revise the theorem and properties. So first, if in a triangle ABC, if line PQ is parallel to side BC, one of the side of the triangle, then the basic proportionality theorem by basic BPT, if a line is parallel to one of the side of the triangle, then by BPT AP upon PB is equal to AQ upon QC. Basic proportionality theorem tells us that when a line is parallel to one of the sides of the triangle, then it divides the other two sides in proportion. So here AP upon PB is equal to AQ upon QC is the basic proportionality theorem. Now second, if in a triangle PQR, if ratio is equal, PS upon SQ is equal to PT upon TR. If ratio side other two sides are in proportion, then by converse of BPT, by converse of basic proportionality theorem, this line ST is parallel to side QR. So line ST is parallel to side QR by converse of basic proportionality theorem. Now third, if in a triangle ABC, if ray BD is bisector of angle ABC. If ray BD is bisector of angle ABC, then by angle bisector theorem, AB upon BC is equal to AD upon BC. AB upon BC is equal to AD upon BC by angle bisector theorem. Fourth one, if in a triangle APQR, if in triangle PQR, PQ upon QR is equal to PS upon SR. If PQ upon QR is equal to PS upon SR, then by converse of angle bisector theorem, ray QS bisect angle PQR. Then by converse of angle bisector theorem, ray QS it bisect the angle PQR. Now last property of three parallel lines and their transversals. By property of three parallel lines and their transversal, if three lines are parallel, if line AP is parallel to BQ is parallel to CR, then and L and M are their transversal, then here AB upon BC is equal to PQ upon QR. It divides this lines in the proportion. These parts are in the proportion that AB upon BC is equal to PQ upon QR. First example. Given below are some triangles and length of line segments. Identify in which figure ray PM is bisector of angle QPR. So first example, here in triangle PQR, length of sides are given. So here PQ upon PR, PQ upon PR is equal to PQ is 7 upon 3 and QM upon MR is equal to 3.5. QM is 3.5 upon MR is 1.5. Now for this ratio we can give a common multiple. So multiply this ratio by 2, both numerator and denominator, multiply by 2. So 3.5 if you multiply or divide the ratio by any number, same number, the value doesn't change. So your value will not change. So 3.5 into 2 is equal to 7 and 1.5 into 2 is equal to 3. So here in this triangle PQR, in the triangle PQR, PQ, therefore PQ upon PR is equal to QM upon MR. Both ratios are equal, QM upon MR. So in triangle PQR, PQ upon PR is equal to QM upon M. Therefore, by converse of angle bisector theorem, angle bisector theorem, ratio is equal. Therefore, PM, ray PM is the bisector of angle QPR, angle QPR. Second example, in triangle PQR, here PR upon PQ, PR upon PQ is equal to, PR is 7 and PQ is 10, 7 upon 10. Then Rn upon NQ, Rn upon NQ is equal to 6 upon 8. So here divide by 2, 2 3s are 6, 2 4s are 12, that is 3 upon 4. Now here ratio PR upon PQ is 7 upon 10 and PM that is Rm upon NQ is 3 upon 4. So here in triangle PQR, PR upon NQ, PR upon PQ, PR upon PQ is not equal to Rn upon NQ. Ratio is not equal. Therefore, ray PM is not the bisector of angle QPR. It is not a bisector of angle QPR. Third example, in triangle PQR, PR upon PQ, PQ upon PR is equal to, PQ is 9 and PR is 10, 9 upon 10, and QM, that is QM upon MR, QM upon MR, that is 3.6 divided by 4. Now this ratio 3.6 upon 4, multiply both numerator and denominator by 10. Multiplying by 10, both numerator and denominator will get 3.6 into 10 is 36 and 4 tens are 40. Now reducing to the lowest form, here 4 nines are 36 and 4 tens are 40, which is equal to 9 upon 10. So in triangle PQR, therefore here PQ upon PR is equal to QM upon QN upon MR. Ratio is equal. Therefore, by converse of angle bisector theorem, ray PM, this ray PM is the bisector of angle QPR. It is the bisector of angle QPR. Question number second. In triangle PQR, PM is equal to 15, PQ is equal to 25, PR is equal to 20, NR is equal to 8. State whether line NM is parallel to side RQ. Give the reason. So let us consider in triangle PQR. Now if you see side here, this PR is equal to PN plus NR. Betweenness P dash N dash R. Therefore PR is given 20 is equal to PN we have to find plus NR is equal to 8. Therefore PN is equal to 20 minus 8. Therefore PN is equal to 20 minus 8 is equal to 12. So PN is equal to 12. The same manner PQ. Now PQ is equal to PM plus NQ. PM plus NQ. Therefore PQ is given 25. 25 is equal to PM is 15. Length PM is 15 plus NQ. NQ we have to find. Here also there is betweenness. N is between P and Q. P dash M dash Q. Now here NQ. Therefore NQ is equal to 25 minus 15. Therefore NQ is equal to 25 minus 15 is equal to 10. NQ is equal to 10. Now in triangle PQR, in this triangle, now here PN we got as 12 and NQ is equal to 10. So the ratio PN upon NR is equal to PN is 12 upon 8, that is 12 divided by 8, reducing to the lowest form. 4 2s are 8, 4 3s are 12, that is 3 upon 2. And the ratio PM upon NQ, PM upon NQ is equal to PM 15 upon NQ 10. 5 3s are 15, 5 2s are 10, that is 3 upon 2. Now here ratio is same. Therefore PN upon NR is equal to PM upon NQ. In triangle PQR, this PM upon NR is equal to PM upon NQ. Therefore ratio is equal. Therefore by converse of basic proportionality theorem, line NM is parallel to side RQ of a triangle PQR. Third example, in triangle MNP, NQ is the bisector of angle N. If MN is equal to 5, PN is equal to 7, NQ is equal to 2.5, find QP. You have to find QP. So here in triangle N and P, ray NQ is bisector of angle M and P, that is angle N. Therefore by angle bisector theorem, so here NM upon NM or MN upon NP, MN upon NP is equal to NQ upon QP, NQ upon QP. Therefore MN is equal to 5 upon NP 7 is equal to NQ 2.5 divided by QP, which we have to find. QP we have to find. Therefore, cross multiply here, QP into 5 is equal to 7 into 2.5. Do the cross multiplication. Therefore, QP into 5 is equal to 7 into 2.5. Therefore, QP is equal to 7 into 2.5 divided by 5. Therefore, 5 ones are 5. 5 0.5 are 25. Therefore, QP is equal to 7 into 0.5, that is 3.5 units is length Q. Example, measures of some angles in the figure are given. We have to prove that AP upon PB is equal to AQ upon QC. So, in triangle, in the given figure in triangle ABC, in angle, see here angle APQ and angle ABC, both are 60 degree. So, angle APQ is equal to angle ABC is equal to 60 degree. Now, these two angles are congruent. We'll consider AB as a transversal. Then, these two angles are corresponding angles. They are corresponding angle. So, by corresponding angle test, if corresponding angles are equal, then by corresponding angle test, the line is parallel. So, line PQ is parallel to side BC of a triangle ABC. Therefore, in triangle ABC, PQ is parallel to side BC. Therefore, when a line is parallel to one of the side BC, then by basic proportionality theorem, ratio, it divides the other two sides in same proportion. So, AP upon PB is equal to AQ upon QC. Fifth example, in trapezium ABCD, AB is parallel to PQ and PQ is parallel to DC. AP is equal to 15 and PD is equal to 12. QC is equal to 14. Find BQ. So, by property of three parallel lines and the transversal, these three lines AB is parallel to PQ and PQ is parallel to DC. Therefore, we get AP upon the parallel lines are divided by transversal in the proportion. So, AP is equal to PD. AP upon PD is equal to BQ upon QC. So, AP is given. Therefore, 15 upon 12 is equal to BQ. We have to find BQ upon 14. Now, do the cross multiplication for 15 into, therefore, 15 into 14 is equal to BQ multiply, cross multiplication, BQ into 12. Therefore, BQ is equal to, BQ will be equal to 15 into 14 divided by 12. So, 15 into 14 upon 12. Now, divide here, 2 7s are, 2 6s are 12, 2 7s are 14 and 2 6s are 12, 3 2s are 6, 3 5s are 15. Therefore, BQ is equal to 7 5s are 35 upon 2, divide 35, 2 1s are 2, 1 carry, 2 7s are 14 and 2 5s are 10. So, BQ is equal to 17.5 units.